Fascinating Frontiers, episode 107. It's June 20th, 2026. Some fascinating developments to cover today. JWST has imaged a galaxy cluster so massive and concentrated that it formed when such structures were not expected to exist yet. A team at IPSAC Caltech has published 3 papers on a distant galaxy cluster observed by JWST. The cluster shows strong gravitational lensing and is the most distant example yet found. Its mass and concentration appear too advanced for the epoch when it existed. The data challenge standard timelines for structure formation. Additional JWST pointings and ground-based spectroscopy are planned to measure member galaxies and dark matter distribution. If the universe were scaled so that 1 billion years equaled 1 meter, the first massive galaxy clusters would appear when the tape had barely reached the 2-meter mark. JWST's new images show one such cluster already packed with galaxies and dark matter when the cosmos was less than 1.5 billion years old. Gravity normally needs more time to pull together structures this large from the smooth gas left after the Big Bang. The cluster's strong lensing of background galaxies reveals a total mass several times that of the Milky Way, concentrated within a region only a few 100,000 light-years across. Yet models built on earlier data predicted far smaller groupings at that epoch. The tension leaves open whether early dark matter halos collapsed faster than expected or whether feedback from the first stars somehow accelerated assembly. No current simulation reproduces both the observed mass and the tight concentration simultaneously. Now, shifting to our own star, new models suggest Earth could avoid being swallowed when the Sun expands. Earlier calculations assumed a larger maximum radius for the dying star. Revised mass loss rates and orbital migration now place the Sun's outer layers inside Earth's current orbit, but not far enough to engulf the planet. The outcome still depends on how much mass the Sun sheds in its final stages. Astronomers will continue refining the models with better stellar evolution data. The finding does not change the long-term uninhabitability of Earth from rising solar luminosity. On a different note, a commercial spacecraft is being developed in 9 months to rendezvous with and raise the orbit of the Swift Observatory. The Swift Gamma Ray and X-ray telescope is losing altitude and needs a boost to continue operations. Engineers are testing docking mechanisms and propulsion systems sized for the small observatory. Success would extend Swift's science return by several years. The effort is the first attempt to rescue an operational NASA astrophysics mission with a privately built vehicle. The Swift rescue mission stands out because it compresses an entire spacecraft development cycle into 9 months. Engineers must integrate propulsion, docking hardware, and guidance systems that normally take years to qualify. Success would prove that commercial teams can respond to orbital emergencies on short notice. The outcome will directly affect whether other aging science satellites receive similar life extension flights. What remains unclear is how much margin the new booster will retain after the initial orbit-raising burns. A rocket carrying the spacecraft designed to raise Swift's orbit left NASA Wallops Flight Facility Thursday. The airplane will release the rocket at altitude for a high-altitude launch. The mission timeline remains compressed to meet the observatory's declining orbit. Ground teams will monitor the ascent and early orbit raising burns. Data from this flight will inform future commercial servicing demonstrations. The launch marks the first operational use of the new boost vehicle. Next up, a private company will design, build, and launch the Aeolus spacecraft for NASA. The probe will deliver the first daily global measurements of Mars' atmospheric environment. Launch is targeted for 2028. The mission focuses on weather patterns and dust cycles rather than surface geology. Data will support both science and future landing operations. This marks the first time a non-SpaceX commercial provider has been selected for a dedicated Mars orbiter. NASA's plans for sustained lunar presence require standardized construction rules to protect both hardware and future crews. A single expert has outlined how differing national standards could create incompatible landing zones and habitats. The proposal draws on terrestrial building codes, but accounts for lunar dust, thermal extremes, and seismic activity from impacts. Without agreed rules, overlapping infrastructure risks could delay Artemis follow-on missions. The discussion centers on technical requirements rather than legal frameworks. Regulators and agencies will need to align before large-scale construction begins. A policy paper recommends that any future lunar base include a facility to isolate potential extraterrestrial organisms. The proposal aims to prevent forward contamination of Earth by return samples or crew. Current planetary protection protocols focus on outbound spacecraft. The paper argues inbound safeguards are also needed. The Moon's isolation offers a natural buffer before material reaches Earth laboratories. Implementation would require new international standards and engineering solutions. Operation Period will collect data on menstrual physiology during spaceflight for the first time. The project addresses gaps in medical knowledge that have persisted since early crewed missions. Researchers will track cycle changes, hygiene methods, and medication needs in microgravity. Results could improve health planning for longer expeditions. The study also aims to reduce outdated assumptions about crew composition. Data collection is expected to begin with upcoming commercial and government flights. Researchers are testing a system that lets astronauts grow pharmaceutical compounds inside modified plants. The method uses synthetic biology to trigger production of specific molecules on demand. It could reduce reliance on pre-packed drugs that degrade over years-long trips. The same approach may also lower costs for medicine production in remote regions on Earth. Early experiments focus on stable compounds that survive space radiation. Follow-on tests will measure yield and purity under microgravity. The open cluster NGC 5897 sits nearly 12 degrees south of Beta Librae, also called Zubineshkamali. At 10:30 p.m. local daylight time, the cluster lies highest in the southern sky for mid-northern observers. Its loose structure and faint stars give it a ghostly appearance in small telescopes. The constellation Libra itself offers a useful reference point for locating the cluster. No special equipment beyond binoculars is required under dark skies. The object remains observable through the rest of June. The International Astronomical Union has assigned asteroid 16,154 to the late musician Elliott Smith. Smith died in 2003 at age 34. The asteroid orbits in the main belt between Mars and Jupiter. Naming follows the standard process of discovery credit and proposal review by the IAU's Committee on Small Body Nomenclature. Observers can locate it with moderate telescopes during favorable apparitions. Future surveys will refine its orbit and physical properties. Astronomers have identified debris from a second supernova near the well-known Jellyfish Nebula. The new remnant shares similar distance and age estimates with the original event. Radio and X-ray observations distinguish the two structures. The discovery suggests the region experienced multiple stellar explosions within a short period. Further mapping will clarify whether the supernovae were triggered by the same molecular cloud. Work on the Deep Synoptic Array will start in rural Nevada this year. The telescope will map large numbers of galaxies at radio wavelengths with high sensitivity. Scientists expected to reveal previously unseen structures and star formation histories. The array's design allows rapid surveying of wide sky areas. Early science operations are planned within a few years. ESA member states met to approve upcoming crew assignments and international cooperation agreements. The decisions cover flights to the International Space Station and future lunar opportunities. New partnerships with commercial providers and other agencies were also formalized. The meeting sets the near-term manifest for European astronauts through the late 2020s. Details on specific missions will be released as contracts are finalized. Short nights and prominent summer constellations make the current season beginner-friendly. Bright stars such as Vega and Arcturus remain visible even in suburban skies. Simple star charts or phone apps can guide new observers to major constellations. No special equipment is required to enjoy the Milky Way's summer appearance. The window lasts through the month before nights lengthen again. Keep an eye on further details about the Aeolus Mars orbiter as contracts move forward. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Unintended Consequences a listen. True stories of good intentions that backfired. You can explore the whole lineup at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.